Hi guys, today we're going to talk about how to solve one variable polynomials. Before we start, there's a few things you need to know. That polynomials are linear equations, which are a sum of variables and exponent expressions. Each piece of a polynomial is called a term. There's always a leading term and a constant term. The leading term always has the highest exponent, and the constant term will always have a zero exponent. Polynomials are written with terms in descending order depending on the exponents. The largest exponent determines the degree, which tells you how many roots you will solve for. Okay, here's a general setup. You have a second degree, a third degree, and a fourth degree. They're all in descending order, as you can tell. 2, 1, 0, 3, 2, 0, 4, 3, 2, 0. The degrees tell you how many roots I'll be solving for. For a second degree, there will be 2 roots. For a third degree, there will be 3 roots. And for a fourth degree, there will be 4 roots. Okay, here's some more general examples. So the first one is a degree of 12 because the highest exponent is 12. The second one is a degree of 4 because the highest exponent is 4. As you can tell, the degree goes by the highest exponent. So the 56 to x to the 23rd, the degree is 23. 5x minus 7, the degree is 1. I already wrote the 1 in, but in any general math sense, the 1 would never be there because the 1 is just imaginary. It's determined and it's already preset. Now for 8, there's no x, so the degree is 0. First, you need to determine what you're being asked. Solve for x when is a value, but it's basically plugging in. Down here is asking to plug in x is 5. So you're going to solve for this expression when x is 5. Or you can solve for the roots. Down there at the bottom, it says 3x to the third equals 12x. So you know you will have 3 roots to be solving for. Okay, now let's do some examples. First, you have to determine the number of roots you're going to look for by determining the degree of the polynomial. For this one, the highest exponent is 3. So first, we're going to set it to where all expressions are on the same side. You're going to have x3, x to the third, plus 30x, and you're going to move over negative 13x squared. It's going to be plus 13x squared equals 0. Now, you can either put this in descending order, but it doesn't really matter, but I'm going to do it anyway. And now we begin to solve. So now you do factoring. You figure out the greatest common factor right now. And there's no number that's the greatest common factor, but you know you have an x all the way around. So you pull out an x and you have x squared plus 13x plus 30 equals 0. Next, you factor again. What does 13 and 30 have in common? Well, 30 gives you 10 and 3 will give you that, and then 10 and 3 will also give you 13. So you factor by doing the full method and the factoring rules. You have x plus 3 times x plus 10 equals 0. Next, you do the zeroing method where you set every multiplication to 0. So it'll be x equals 0, x plus 3 equals 0, and x plus 10 equals 0. Next, you solve for x. X equals 0, x equals negative 3, and x equals negative 10. These are your roots. Okay, here's the next example. We have 6x third minus 16x equals 4x squared. We're going to move everything on the right-hand side to the left-hand side and also put them in descending order. There we go. Next, we're going to use factoring strategies to factor the problem. We can pull out a 2x here. So that's our greatest factor. So you can put 2x, x 3x squared minus 2x minus 8 equals 0. Next, we can factor the inside. And from the inside, we have 3x squared minus 2x minus 8. You can put a 3x, because to give you 8, you have 4 and 2. And then 4 minus 2 gives you 2. So you have 3x plus 4. And then x minus 2. And that equals 0. Next, you put everything in the zero product property or the zeroing out rule. So you have 2x equals 0. 3x plus 4 equals 0. X minus 2 equals 0. Now you solve for x. X equals 0. 3x equals 4. And now x equals, and that's supposed to be a negative 4. And x equals negative 4 over 3. Here, x equals 2. So these are your 3 roots. Also, if you have any problem factoring, because I know factoring is difficult, there are going to be more little links in the description. Okay, let's do another one. 36x equals 40x squared minus 4x to the third. We're going to solve for the roots. We know the highest exponent is 3, so that means we're going to have 3 roots. First, we're going to move everything on the right-hand side to the left-hand side to make it all equal 0. This sets it up in the general form I showed you earlier, where it's the third degree. Next, we're going to factor. First, we're going to pull out the greatest common factor. And the greatest common factor here is 4x. So pulling out a 4x out of the first expression right here, you get x squared minus 10x plus 9. Next, you do another factoring strategy. We know that 9 is 9 times 1. And also, negative 1 and negative 9 gives you negative 10. So those are the two numbers we're going to use. Next, we'll just set everything that's multiplication equals to 0. So we'll have 4x equals 0, x minus 1 equals 0, x minus 9 equals 0. And now we solve for x. Here, x is 0 because 4 divided by 0 divided by 4 is 0. Here, x is 1. Here, x is 9. Here are your 3 roots. Okay, let's do the very last one. We have 3x squared times 3x plus 4 equals 12x times x plus 3. First, we're going to multiply out both sides, and then we're going to move everything on the right-hand side to the left-hand side. Let's start it up. 3x squared times 3x plus 4 gives you 9x to the third plus 12x squared. 12x times x plus 3 gives you 12x squared plus 36x. Now we're going to move everything on the right-hand side to the left-hand side. Now, as you can tell, we have two values here that are the same. So, they're going to cancel out, as you know, because you're going to subtract this 12 from this 12. So now we have 9x to the third minus 36x equals 0. We can pull out a 9x because that is the greatest common factor here. So we'll have 9x times x squared minus 4 equals 0. Next, we do more factoring strategies for the inside. So we have 9x times x plus 2, because 2 and 2 will give you 4. And then we have x minus 2 equals 0. This plus and this minus will also cancel out. Up here will be no 2x in there at all. Now we have 9x times x plus 2 times x minus 2. Now you do the 0 factoring rule where you set everything to 0. So you have 9x equals 0, x plus 2 equals 0, x minus 2 equals 0. Here, x will equal 0 because 0 divided by 9 is 0. Here, x will equals -2 because you move the -2 to the other side. Here, x will equal 2 because you move the 2 to the other side. And these are your 3 roots. Okay, thank you for watching. I hope you enjoyed what I have taught you today. I hope you understood what I was saying. Leave comments if you want or not. I'm probably not going to put this up to view for everybody. Also, there are links in the description for factoring and more links on how to solve polynomials that give you more information that I did not give you today. Thank you.